So, hello everyone. I will present you estimation of diffusivity in the TReX experiment. So, TReX experiment, here is two picture. I have data from September 11 in 2020 and for all the day between September 5 and September 9 in 2021. First thing to do is the geolocalization of all the picture. So once I did that, I have to make a validation with the colorlist direction and position, which I get from the anemometer. Once this is done, I can compare the red intensity from the picture with the dye concentration measured by the fluorometer, which will give us the following result. And we found that the photograph that the drone can see the dye up to a depth of 3 meters. Here, the red intensity is the red channel minus the average between the green and the blue channel. After that, we create mosaics for each survey. Here is 3 examples. The left one is good. In the middle, I have a lot of sun and reflection. And on the last case, I have lower dye concentration. Speaking about the dye, I will use those mosaic to estimate spatial distribution. And once we have the spatial distribution, I can get the moment, and from that define the covariance matrix with the zonal variance, with the meridional variance, and with the covariance. After that, we will see the covariance matrix as a covariance ellipse and define the variance along the major and the minor axis with the following definition. After that, we use the strain diffusion model, that's equation 2, to define the equation for the variance along the major and minor axis. That's equation 3 and 4. From that, we have a theoretical solution, and the goal here is to find the diffusivity and the deformation rate. So we will make estimation for the major axis, another for the minor axis, and the good diffusivity and deformation rate will be when the diffusivity for the minor meet the one for the major axis. This is just to show that our estimation, our theoretical estimation, are in good agreement with the measurement, with the measured variance. Then we will focus just in one day, which is 11th September, and I will compare the diffusivity estimated from the strain diffusion model I just showed, from the strain free model, and what we do usually with Twifter. So this is the strain free model. It's really easy. We just consider that the deformation is very small, and we have an approximation. So now, if we compare the diffusivity from the Twifter with the one from the strain free and strain diffusion model, we will have the following picture, and we can see that the strain free model gives diffusivity really close to the one from the Twifter, but when we consider the deformation, we have a lower value. If I compare the diffusivity by the diffusivity estimated with the diffusion only model, with the one using the deformation, I will have a value always larger when I use no deformation, which gives me the following conclusion. When the weight from aerial image is best correlated when I consider the first 3 meta, then when we consider the diffusivity, the deformation free give always much higher value than the deformation diffusion model. And this kind of show that the horizontal diffusivity from drifter are always overestimated. Fini.